Hey everyone, today we're going to talk about modeling with equations. We're going to do some review of solving word problems just to refresh your memory a little bit. So, a lot of people struggle with word problems, or they think they struggle with word problems, and I think it's because they don't necessarily have a strategy for attacking them. And so I like to talk about this first because they really become pretty basic if you just take it one step at a time, right? So we'll start with the most basic of things. You have to read through the problem and then determine what your unknown variable is. Okay, you might have more than one unknown, but let's start with one of them. We'll let x represent that variable. As we move through the problem and there's other unknowns, then we'll write those in terms of x so that we can write an equation in terms of x that models the problem. We'll go ahead and solve it, and then we'll check the solution. And when we refer to checking the solution, we don't just mean making sure that we did the math correctly, but we also mean making sure that we answer the problem that's being asked, answer the question that they're asking us, and make sure our answer makes sense. So we'll do a couple of practice problems. We'll start here with a problem about a brand new car. Okay, and the first thing to note here is that they're talking about depreciating. And two things, because sometimes people forget this, right? When we talk about depreciation, that means that the car is losing value. When we talk about appreciation, it means that the car, or any other object for that matter, is gaining in value. So depreciating means it's losing value. Says that we start with $45,000 car. It's depreciating $5,000 a year, so it's asking us to write a formula representing that. Okay, and it's telling us what y is and it's telling us what x is. And I could go through and write the let statements here, but it says right in the problem what those are, so I'm not going to rewrite those out. So the first thing it says is to write a formula. All right, well, I know that y is the car's value. I know that the car starts at $45,000, and I know that it's depreciating, so it's losing value $5,000 per year. So after 1 year, it's lost 5,000. After 2 years, it's lost 10,000, etc., etc. Okay, so that's the first part. That's our formula. And now it's saying to use the formula to determine after how many years the car's value will be 10,000. So it's telling us what we're actually looking for. We're trying to determine after how many years. So we're solving for x. We know that the car's value is going to be $10,000, and we just want to know after how many years it's actually worth 10,000. So I'm solving this problem for x, solving this equation for x. Very basic, straightforward linear equation solving. Subtract 45,000 from both sides. Then divide both sides by negative 5,000, and we end up with x. Make sure you label 7 what? 7 elephants, 7 bananas? No, it's 7 years. Okay? Just make sure that you label the problem. So that one's pretty straightforward. Just getting our feet wet a little bit here. Let's talk about a population problem. Okay, so they're telling us in the year 2000, population of Greece was 10.6 million, expected to decrease 28,000 per year. In that same year, so in the year 2000, the population of Belgium started out at 10.2 million, and it's expected to decrease at 12,000 per year. So it's asking you, when will the two countries have the same population? So there's two important things in here. When will they have the same, or when will the two countries have the same population? So those are our two key parts of this question. Their same population is going to be when they're equal to each other. When is going to be x, right? Because that's what they're asking us to find, the number of years. So let x equal number of years. Okay, and we're going to write an equation to model our problem. So Greece has 10.6 million people, and they're losing people. They have a population decrease of 28,000 per year. And when is that the same? So when is that equal to Belgium's population of 10.2 million people, and they're decreasing at 12,000 per year. Again, a very basic problem to solve. It's a linear equation. We're just going to get all of our constant terms to one side and all of our x terms to the other. So if I move my terms, I end up with 400,000 because I'm moving my constant terms to the left. I'll move my x terms to the right. So I end up with 16,000x. Divide both sides by 16,000 and I end up with x is 25. Now, make sure that you answer the question, when will the two countries have the same population? Well, if it started in the year 2000 and it's 25 years later, that would be in the year 2025. Okay, so that's the answer to the first part of the problem. The second question here asks, what will the population be at that time? Well, that's, again, very straightforward. You can choose either part of the equation to solve in, but all you're going to do is substitute 25 in for x, and when you solve that, you get 9.9 million or 9,900,000. So again, everything is written right in the problem. Okay, you just have to make sure you decipher it one step at a time. Now this one is talking about swimming pool. These problems you've probably seen before, maybe not in a while, but you have seen them before. We have a swimming pool that measures 40 feet by 60 feet. So that's, and I know that's kind of hard to read. I'll change my pen color in a second here. But 40 by 60, that's the white box. That's my swimming pool. Okay. Here is the next part of the problem. And all of these little sections here are this uniform width of the path that goes around the four edges of the pool. And that's all the same width. And so I'm going to call that x. Okay? This width here is x. This width here is x. This one here is x. And this one here is x. And so when I look at this entire length here, if the white part is 60 and then I have x and x on either end, then the entire width here is going to be 60 plus 2x. And I can do the same thing on this side. If this width of the pool was 40, then this entire segment here is going to be 40 plus 2x. And those are the dimensions of my pool plus my path around the pool. And then the next important piece of information is that the perimeter of that whole rectangle is 248. So let's first say what x is. Let x equal the width of the path. Okay? And now the other important piece of information we have here is the perimeter. And we know that perimeter, 2 times the length plus 2 times the width is equal to the perimeter of our rectangle. So 2 times the length, so 2 times 60 plus 2x plus 2 times 40 plus 2x gives us our perimeter of 248. Again, it just becomes a very straightforward linear problem. You're just distributing and then combining your like terms. You end up with 8x plus 200 is equal to 248. So 8x is 48. So x comes out to be 6. 6 what? That's 6 feet. And then that's your answer. Make sure that that makes sense, which it does. Okay. All right, moving on to the last problem. This one's a little bit more involved. Tends to scare people a little bit when you start adding in these other things here. But it's talking about an engine pulling a train 140 miles. Second engine has a velocity 5 miles an hour faster, takes over and now pulls the train 200 miles. It tells you that the total time required is 9 hours. And then it says find the average velocity of each engine. Think back You probably did this a while ago. Distance is equal to rate times time. We're trying to find that rate or that average velocity. Yeah? So, we can look at this a couple of different ways. But what I want to do is I like to make a little kind of a chart here, right? We've got this first train. So we've got train 1 and we have train 2. Okay? Train 1 is traveling it travels a distance of 140 and is traveling at a rate of r. Okay? We have train number 2. It travels actually 200 miles and its rate is just 5 miles per hour faster than the other one. Now these combined times is 9 hours. It's giving us all of that information in the problem. But let's go ahead and write out an equation. I know that the total amount of time is 9 hours, and that has to be the time of the two trains together, right? So the time of train 1 plus the time of train 2 has to equal 9 hours. If I rewrite this equation as time is equal to distance over rate, then I can go ahead and plug those in for my two trains, right? So 9 hours is my total time traveled. My distance for the first train was 140, traveling at a rate of r. My second train traveled a distance of 200 miles at a rate of r plus 5, and those times together adds up to 9. So there is my equation. With that, then, I have a fractional equation, right? I have these fractions as actually an algebraic a rational expression equation. And so what I need to do is multiply through by my common denominator to get rid of my denominators. Okay, so then that means I would be multiplying every term by r times r plus 5. And so if I do that, I have 9 times r squared plus 5r. Here my r's cancel, so I'm left with 140 times r plus 5. And then I have 200 times r, because here my r plus 5's cancel out. Okay. And when I go through and distribute, and just in the interest of time, I'm going to do this real quick, distribute everything and move everything over to one side, and with 9r squared minus 295r minus 700 is equal to 0. You can try and factor that if you want to. It might take a while. Once you have numbers this big, I tend to go towards the surefire way to solve it, and I just go with the quadratic formula. When you do that, you end up with r equals 295 plus or minus the square root of 295 squared minus 4 times 9 times negative 700, all of that over 2 times 9. When you simplify that, again, just in the interest of time, you end up with 295 plus or minus 335 over 18. Obviously, you have to use the plus one, because if you use the minus option, you would get a negative number. You can't have a negative rate. So you end up with the rate of 35. Make sure you label it miles per hour. That's the first engine, which means that the second engine would be 40 miles per hour. Okay, so that's just an example of how to do some different types of word problems. So make sure you review those before you go ahead and do today's assignment. Have a great day, everybody, and I'll have a video for you again tomorrow. Take care, everybody. Bye-bye.